Somewhere past the edge of the planets, a tiny machine is still carrying humanity's name into the darkness. Voyager 1, launched in 1977, before smartphones, before the internet, before most of you watching this were born. No vacations, no repairs, no second chances, just endless motion through space every second for almost 49 years. And in a few months, on November the 18th, 2026, it will cross a milestone no human-made object has ever reached, 1 light day from Earth. The distance light covers in 24 hours. Think about that. Nearly half a century of non-stop flight just to close in on the distance light crosses in a single day. So here's the question that should actually bother you. If 49 years only gets us to 1 light day, what does 1 light year actually demand? That's the moment space stops feeling exciting and starts feeling impossible. Let's start with what we're actually measuring. Light moves at nearly 300,000 kilometers every second. In 1 second, it could circle the Earth more than 7 times. In 1 hour, over 1 billion kilometers. In 1 day, almost 26 billion. Now keep that going, week after week, month after month, without slowing, without stopping, for an entire year. The result, 9.46 trillion kilometers. That's 1 light year. But a number like that doesn't mean anything on its own. So let's shrink it down to something human. Imagine driving a car at 100 kilometers an hour forever. No traffic, no sleep, no stopping. At that speed, 1 light year would take over 10 million years. Human civilization isn't even that old. Try a fighter jet instead. Still hopeless. The fastest bullet ever fired, meaningless against this distance. And that's when it hits you. The problem was never that space is big. It's that nothing in our daily experience was ever built to understand how big. Most people assume that once a rocket leaves Earth, it's finally in deep space. It isn't. Not even close. To break free of Earth's gravity, a spacecraft needs to hit roughly 11.2 kilometers per second. Faster than a bullet. But Earth was never the real prison. The sun is, every planet, every asteroid, every comet. All of it is still caught in the sun's gravitational grip. And so is anything we launch. So where does our solar system actually end? Most people would say Pluto. Pluto isn't even close. The sun's true influence, the heliosphere, stretches out to roughly 120 astronomical units before the solar wind finally loses to interstellar space. And beyond that, the Oort Cloud. Current models suggest this shell of icy debris may stretch a full light year out in every direction, though its true edge has never been directly observed. Which means something almost absurd. What's left is still more crowded than interstellar space. On average, the gas between stars comes out to about 1 atom per cubic centimeter, thin enough that nothing is the honest word for it. Now imagine flying through that for years, no landmarks, no mile markers. 1 week looks exactly like the next. You're moving, but visually it's as if you've stopped. Here's the part almost nobody talks about. The greatest danger out there isn't a giant asteroid, it's something you could balance on a fingertip. A single grain of dust. Harmless on Earth, but at a meaningful fraction of light speed, that same speck becomes a high-energy projectile, carrying enough kinetic force to punch through a hull. Then there's the radiation. Out past the heliosphere, there's no planetary magnetic field standing guard. Cosmic radiation hits, unfiltered for years at a time, and we don't yet have shielding that reliably protects a human body over that kind of exposure. So you add mass to shield against it, which makes the ship heavier, which demands more fuel, which adds more mass. It's a loop that punishes every solution. The biggest obstacle to reaching another star was never speed. It's everything speed creates. Let's make this concrete. 3 real speeds, 1 light year, very different outcomes. Voyager 1, moving at 17 kilometers per second. At that pace, 1 light year takes about 17,000 years, roughly the span from the first cave paintings to tonight. For 1 light year, the Parker Solar Probe, our fastest machine ever built. At its closest solar approach, it hit about 692,000 kilometers per hour, roughly 192 kilometers per second. Even at that speed, 1 light year would take close to 1,500 years. A civilization could rise and fall in that window. Breakthrough Starshot, not a real mission yet, just a proposal. Postage stamp-sized probes pushed by lasers to 20% of light speed. At that pace, 1 light year takes about 5 years. Suddenly the math looks almost reasonable. Almost, because that number comes with an asterisk the size of a planet. We're talking about a probe with a mass measured in grams. No crew, no shielding, no way to slow back down. The moment you add a human being to that equation, the 5-year number collapses with it. Say we solve all of it, we cross the full light year. Here's what that actually buys you. Proxima Centauri, our nearest stellar neighbor, sits 4.24 light years away, which means after covering an entire light year, you haven't even reached a quarter of the distance. Not halfway, not a third, not a quarter. And for most of that journey, Proxima wouldn't even look closer. Stars are so distant that for years, they'd sit frozen against the black, barely brightening, while your ship raced forward at a meaningful fraction of light speed. Meanwhile, behind you, something stranger happens. The sun, the star that has shaped every sunrise, every harvest, every heartbeat of human history, quietly stops being special. It fades into just another point of light, indistinguishable from the thousands around it. That's the real cost of a light year, not just distance, perspective. Zoom out one more time. Shrink the entire solar system down until Earth sits 1 meter from the sun. At that scale, Neptune is still 30 meters out. The Oort Cloud, that light-year-wide shell around us, hasn't even started yet, which means a journey that costs a civilization's lifespan might not even get you out of our own front yard. And beyond that front yard, the numbers stop being humbling and start being absurd. Within just 50 light years of Earth, there are thousands of stars. Compared to the galaxy, that entire neighborhood is nothing. The Milky Way spans over 100,000 light years. One full orbit around it takes roughly 230 million years, longer than the dinosaurs existed. So how long would it take to travel 1 light year? Depending on what you're willing to sacrifice, 17,000 years, or 1,500, or 5, if you weigh less than a coin and never plan on slowing down. None of those numbers were ever the hard part. The hard part was everything hiding behind them. Right now, Voyager 1 is still closing in on its first light day, a milestone it will finally reach on November the 18th, 2026, after 49 years of uninterrupted flight. A light year is 365 of those days. Voyager won't live to see one. Neither will the people who built it. The stars aren't just far. They're far in a way that outlives the machines we send and the hands that launched them. And somewhere past the edge of everything we've ever sent, the real distance hasn't even introduced itself yet. Thank you for watching, Nova Dread. See you soon with a new topic.